Alright guys, another week at math. We are on lesson 7.6. Hope you guys are doing great and getting all your lessons in and checking MyStar. Make sure you're getting your points so that you can get credit for this last trimester for the year. Okay, so in lesson 7.6, this is on page 334. We're going to be solving inequalities using addition and subtraction today. So the first couple examples are going over addition. So hopefully you remember from the beginning of the chapter how to solve equations. So making the fence under the equal sign, circling the number on the variable side, using the inverse operation. You can go back and look at your notes from the beginning of the chapter, or hopefully that's ringing a bell. So again, your books don't do the fence method, but I will do the fence method in all the examples I give you. You can see that they're adding the same number to both sides, they just don't have the fence. The only difference between an equation and inequality is equations have equal signs and inequalities use inequality symbols. So you can pause the video, refresh your memory, seeing what's happening there. Here's an example 1. Again, they don't have the fence, but whatever they do to one side, they are doing to the other. Oh boy, here we go again. Okay, there we go. And so I am just going to show you how to solve these inequalities at the bottom and then graph them. So we're going to kind of review what we did at the beginning of the chapter and then graphing our solutions, which is what you learned to do last week. So here are my notes, so feel free to grab your ISN or your notebook or wherever you're adding notes. In this lesson, we're going to be adding and subtracting with our inequalities. So solve using the same process we did when we solved equations. So I kind of did a shorter version of those notes right here. These are our steps. Remember, we're going to make a fence, but this time it's going to be under the symbol, whatever the inequality symbol is, no equal sign. We're still going to circle the number on the variable side. We're going to use the inverse operation, and whatever we do to one side, we're going to do to the other side. And remember, the inverse operation is just the opposite. And then we're going to solve, and then we're going to check to see if that answer makes sense. So, solving this one, I'm going to make my fence under the inequality symbol. Circle the number on the variable side. Minus 2, what's the opposite or the inverse operation of a minus 2? Plus 2, and I'm going to do that to both sides. This cancels out. I'm left with an X. Keep the same symbol. And 3 plus 2 is 5. And now if I were to graph that, I'll sneak this in right here. 5, 6, 7, 4, 3. Now I gotta think of a number that is less than 5. Well, 4 is less than 5, 3 is less than 5, 2 is less than 5. Okay, so now I gotta put a dot on the 5. You should be asking yourself, is it going to be open or is it going to be closed? No equal, no extra color. So it's going to be open dot, and I'm going to point it towards the numbers that make that statement true. And there I'm done. So I'm going to go ahead and do 2 and 3 right here. So once again, make your fence under the inequality symbol. Let's see. Ooh, a little bit brighter. Sun's going down. Okay. So now circle the number on the variable side. I'm just following these steps every single time. Now I'm going to use the inverse operation. If this says minus 6, I'm going to add 6. Whatever I do to one side, I must do to the other. This cancels each other out. I'm left with x. I bring down my symbol, and I solve this side. 4 plus 6 is 10. I already got a number line ready, otherwise I would just go ahead and make one, but trying to save time. So think of a number that is greater than 10. Well, 11 is greater than 10. 12 is. 13 is. Now I have that extra line here, so I need to include some extra color, and that's going to be a closed dot, closed circle. Remember, extra line, extra color. No extra line, no extra color. So now I'm going to point my arrow in the direction of my numbers that would make that statement true. And there you go. Let's do one more, number 3. Make your fence under the inequality symbol. Circle the number on the variable side. It doesn't matter where the variable is, just circle the number on that side. So what's the opposite of a minus 1? Plus 1. Whatever I do to that side, I must do to this side. Cancels out. I'm left with x. Bring down my symbol. 10 plus 1 is 11. So now my x is over here, so I got to still make this statement true. 11 is greater than or equal to. I'm just going to focus on the greater than. 11 is greater than what? Well, 11 is greater than an 8. 11 is greater than a 9. 11 is greater than a 10. So again, you might have picked some different answers, but those are the ones that came to my mind. So greater than or equal to, extra line, extra color, and my dot is going to go on this number, not on these numbers, but on the number that solved my inequality statement. So close dot, close circle, and I got to point it towards my 8, 9, and 10. Well, my 8 would be over here, so I'm going to point it in that direction. And those are those 3 examples. Now we can use this pretty much same process except subtraction. So when we see a subtraction, or I'm sorry, when we see an addition, we're going to use subtraction because the opposite of adding is subtracting. And then we're going to do the same exact thing. So I'm just going to go ahead and do 4, 5, and 6 now. Kind of walk you through some examples. All right, number 4. Same process. Make your fence under the inequality symbol. Circle the number on the variable side. Use the inverse operation. This says plus 3, so I'm going to minus 3 on both sides. Cancels out. I'm left with x. Keep the same symbol. And then solve. 7 minus 3 is 4. So now, right away you can put your dot on. Is it going to be an open or closed dot? Open is correct. No extra line, no extra color. Now think of a number that is greater than 4. I put my symbol on the 4 because that's what it's telling me. Now I'm thinking of numbers that are greater than 4. That's going to make this statement true. Well, 5 is greater, 6 is greater, 7 is greater. If you haven't noticed by now, I usually pick about 3 numbers just to make it true. And then point my arrow towards these numbers. And there's your graph. Alrighty, number 5. Make your fence under the inequality symbol. Circle the number on the variable side. What's the opposite of a plus 2? Minus 2. Whatever I do to that side, I must do to this side. Keep both sides of the inequality statement balanced. Cancels out. I'm left with y. Keep the same symbol. 17 minus 2 is 15. So right away I know my dot is going to go on the 15. Is it going to be an open or closed dot? open is correct. No extra line, no extra color. Now, tell me a number that is less than 15 this time. Less than, well, 14, 13, 12, and then I'm going to point my arrow towards where those numbers would appear. If you're noticing, I'm counting by all different kinds of things. Sometimes I'm counting by 1s, 2s, 5s, 10s. That's up to you. I'm just showing you a variety of different ways. I think the book shows a variety of ways too. All right, now the last one, make your fence. Under the inequality statement, circle the number on the variable side. It doesn't make any sense to circle this 16 and get rid of it, because then I'm left with nothing over here, and my variable is still not by itself. Remember, we're always circling the number on the variable side. Sometimes it's to the left of the symbol, sometimes it's to the right of the symbol. That part doesn't matter. It's always circling the number on the variable side. Because remember, the goal is to isolate the variable. We want to know what our variable could be worth. So we see a +9. I'm going to do the opposite. Inverse operation would be a -9 on both sides. That cancels out. I isolated my variable. Keep the same symbol. And then 16 minus 9 is, oh my gosh, I'm going blank. 7. What did I screw up my number line? Whoa. Did some wrong pre-planning here. I should have a 7 here. 8, 9, 6, 5. All right, so now I have a 7, less than or equal to. My dot's going to go on the 7. I have extra line, extra color. Now, tell me a number that would make this statement true. 7 is less than what? 7 is less than, smaller than. You can substitute a different word if that makes it easier. 7 is smaller than an 8, smaller than a 9, smaller than a 10. So I need to point my arrow in that direction. And that is it for lesson 7.6. You can go on to bigideas.com and do the lesson. Again, there's 10 questions. Remember to hit submit when you are done. And that's it for this one. See you later.